on to the practical applications of our Spacetherm range of products and how they can be used to modernise the energy. Good morning and welcome to today's webinar. My name is Kira Proctor and I'm the Managing Director at the A. Proctor Group Limited, and this is our 7th webinar of 2021. This was originally broadcast 1 year ago. If you've missed any of our series, you can go back and watch them all on demand on our YouTube channel or through our Learning Hub at www.proctorgroup.com, where you can also register for updates, alerts and instantly available replay packs. Today we're going to revisit our look at aerogels in refurbishment applications, and as a lot of refurbishment issues are very project specific, we'll be following up with a brand new live Q&A session. As I'm now on maternity leave, today's Q&A will be hosted by Michalak with our team of technical experts. So any questions you might have, type them into the chat box here on YouTube, DM us on Twitter at Proctor Group or email webinar@proctorgroup.com. You can also get in touch to book follow-up meetings with our team of experts to discuss specific project details, or to get online assistance throughout the specification and installation process. Today, we'll start with a brief overview of the basic physics of thermal insulation and how these apply to refurbishment projects, and a look at how aerogels are manufactured, then move on to the practical applications of our Spacetherm range of products and how they can be used to modernise the energy performance of a variety of existing structures without sacrificing utility or aesthetics. When we talk about insulating buildings, we usually talk about U values. A U value quantifies the rate of heat loss through a building element, such as walls, roofs, windows and doors. The lower the U value is, the slower the heat generated by heating systems will escape from the building, and the less energy input will be needed to maintain a comfortable internal temperature. U values are affected by a law of diminishing returns, so the more insulation we add, the more we need to improve the U value further. So after a certain point, it ceases to be cost-effective or space-efficient to add more insulation. We also have to consider that not all materials insulate equally well, and to define that, we use a value called the thermal conductivity, or lambda value. The lower this value is, the less able it is to conduct heat flow, so the better it will work as insulation. Typical building materials like bricks or metal have a high thermal conductivity, while insulation materials like mineral wool or rigid foams have a far lower conductivity. If we want to account for the thickness of the material used as well, we look at a property called thermal resistance, known as the R value. This is given by the thermal conductivity of the material divided by the specified thickness. To work out a U value, we add all the R values in our wall together and take the inverse of the result. This inverse relationship is what gives us the law of diminishing returns mentioned before. So if we bring all this together, we can take the thicknesses of our materials and divide those by their thermal conductivity to get R values. We can then add those R values together and take an inverse to get the U value. The U value is then adjusted for any penetrations like structural elements called repeating thermal bridges, any fixings or air gaps present, and a few other correctional factors to give us a final U value for the element. The next step is to take all our U values for walls, doors, windows, roofs, and whatever other elements we have in our thermal envelope design, weight them by their respective area, and derive an overall average U value for the entire building. We can then adjust that to account for non-repeating thermal bridges like corner junction, floor zones, etc., and end up with our complete heat loss model. Modern new build homes typically have wall U values of around 0.2 watts per metre squared Kelvin, while traditional older properties with solid walls will be more like 2 watts per metre squared Kelvin, an order of magnitude worse, which will have a significant effect on both the heating bills of the property and the quality of life of the occupants. This is especially true where occupants are considered to be in fuel poverty or belong to a particularly vulnerable social group such as the elderly. In such groups, poor thermal insulation can lead to a variety of health problems, so it's important that upgrading such homes is considered a priority. When we're dealing with historic or listed buildings, however, this priority must be balanced against retaining architectural features and maintaining the character of the building. Significantly improving technical performance while maintaining these aesthetic quality poses a number of challenges. Ensuring that internal spaces remain large enough to be fit for purpose is of particular importance, as is minimising the effect of upgrades on moisture movement. Strategies to upgrade the energy performance of existing buildings must therefore be carefully considered, and considered holistically, as actions affecting one aspect of the building may have unforeseen consequences in another. While successive government strategies have focused on reducing energy use in older buildings, the wider implications of this have not always been fully considered. Designers must therefore have a good understanding of the materials being used in both the upgrade process and the original construction. By recognising that refurbishment cannot simply upgrade thermal insulation without also addressing the balance of moisture movement and air leakage, we can ensure the most optimal upgrade solutions are achieved. Here at the A Proctor Group, we have invested in the importance of HAM principles, the balance of heat, air and moisture movement, and we have products and solutions taking into account all aspects of the building envelope. Types of thermal insulation. There's a great many types of insulation on the market, with a wide range of thermal conductivities. The right choice for a project depends on many factors, but today we're going to focus particularly on refurbishment applications and historic buildings, which, as we've touched on already, often pose specific challenges. The first of these challenges is that older buildings typically benefit from highly vapour-permeable insulation. This is because traditional building materials such as lime-based mortar and plaster have very different hygrothermal properties from their modern equivalents. Adding insulation of low permeability, such as rigid foam, on top of such materials can lead to damaging moisture problems for two primary reasons. Firstly, adding insulation of any type will reduce the temperature of the existing wall masonry, making it more likely that condensation will occur, and will occur further to the inside as there will be less heat penetrating from the living spaces to heat up the masonry. Secondly, some insulation types such as rigid foams can prevent the dying out of condensed moisture inwards into the building, further compounding the problems. If not properly accounted for in the design, this moisture accumulation can continue unchecked, leading to increasing problems with damp and mould over time, and in extreme cases, causing the masonry to degrade due to freeze-thaw cycling. Permeable insulation prevents moisture being trapped in the construction and does not disrupt the established balance of moisture flows within the building fabric to the same degree. However, traditional types of moisture vapour permeable insulation, such as mineral fibre, tend to be very bulky. This leads on to the second challenge in historical refurbishment, preserving interior space. While mineral fibre or natural wool do a good job ensuring moisture can permeate, their relatively high thermal conductivity means achieving modern thermal standards can require up to 200 mm of thickness, which is not always practical to incorporate into an existing space. Aerogel composites such as our Spacetherm, on the other hand, can maintain permeability whilst reducing the required depth dramatically. This makes it ideal for use in rooms with limited floor area, as well as at door and window reveals and other areas, whilst retaining existing features limits the use of thick and bulky insulation. What is aerogel? Aerogel is a very low-density solid that was developed in the 1930s, but has only recently found mainstream uses. An aerogel is a gel in which the liquid is replaced by gas without shrinking via a complex process called supercritical drying. The silica aerogel used in Spacetherm insulation products is essentially puffed up sand, best described as being to sand what a Rice Krispie is to rice. The resultant structure is 97% air, entrapped in nano-sized pores, and whilst a superb thermal insulator, it is very brittle, limiting its practical applications. Spacetherm aerogel takes this aerogel and embeds it into a fibrous mat to achieve a combination of excellent thermal performance and robust flexibility. The thermal conductivity of 0.015 watts per metre Kelvin makes it among the best thermal insulants in use today, which combined with its high vapour permeability makes it ideal in refurbishments. Spacetherm aerogel is also hydrophobic, meaning it actively repels liquid water. Because the aerogel blanket contains no blowing agents, it does not release harmful gases into the building over time, nor does its performance degrade, with extensive testing showing no loss of thermal performance over a 50-year period. Variants of Spacetherm Aerogel are also available with reaction to fire classifications up to A2, making these products suitable for use in almost any situation. Raptherm. At the more extensive end of building refurbishment are facade retention projects, where the majority of the building is demolished and replaced with a modern new build structure, retaining only the facade from the existing structure. While this method resolves a great number of the issues inherent in such projects, by simply replacing the problematic elements and features with modern equivalents, designing an effective interface between what is replaced and what is retained can still be challenging. Air leakage and cold bridging are the most significant problems to be overcome in these areas, so by combining a vapour-permeable, self-adhering air barrier membrane with a layer of high-performance insulation, Raptherm offers a simple and compelling solution to these issues. Raptherm is installed on the reverse of the retained facade stonework in a similar way to many self-adhering damp-proofing membranes. However, as Raptherm is vapour-permeable, it does not adversely affect the movement of moisture through the facade stonework. This helps limit damage that can occur when moisture flow through older stonework is altered, but upgrade works. As well as protecting the existing building fabric, Raptherm's hydrophobic properties provide a secondary barrier to water ingress, and by sealing tightly to door and window frames and other penetrations, also limits heat loss associated with air leakage. The unique layer of aerogel insulation in the Raptherm also effectively limits cold bridging by providing a continuous insulation layer across the back of the facade, so there's a thermal break between the new structure internally and the cold outer stonework, providing a further boost to the energy performance of the upgraded building. By combining these properties into a single material, Raptherm not only speeds up and simplifies the installation process, but it reduces on-site defects and requirements for costly remediation. Spacetherm Wall Liner. While Raptherm is focused on more extensive refurbishment developments, smaller scale projects can achieve the same performance benefits using the Spacetherm Wall Liner. This comprises aerogel insulation bonded to a durable 3mm magnesium oxide facing board and fixed in place internally using a gap-filling adhesive. The panels can then be jointed, skimmed and painted and decorated in the same way as a normal plasterboard wall. It is supplied in a 1200 by 600mm panel weighing just 4.9 kilograms, meaning that sheets are easily handled by one person and can be easily moved to hard-to-reach areas or stored on site without affecting access. Once installed, the system provides a significant reduction in heat loss, with a minimal 13mm increase in wall thickness, meaning in most cases, sockets, switches and TV network points can be left in situ and features such as cornices and window sills can be left as is, with no modification required. It's often the case that meaningful thermal upgrades to older properties are ignored due to the cost and problems associated with such enabling works, and result in unforeseen added costs. Thin systems such as Spacetherm Wall Liner therefore offer specifiers and homeowners a simple option where traditional thermal upgrades are not possible. Even though this system typically won't achieve performance in line with building regulations, even a small upgrade in thermal insulation can raise the internal surface temperature enough to avoid condensation problems. The minimal thickness also allows it to be used on space-constrained areas to ensure continuity of thermal insulation. In our example here, a solid uninsulated masonry wall has a risk of condensation across the whole surface, both the main part of the wall and at the window reveals. If insulation is added to the main wall surface but emitted from the reveals, although the wall surface temperature increases, the surface temperature in the window reveals actually decreases, leading to an increased condensation risk in these areas. Even adding a minimal amount of insulation to the reveals will elevate this temperature by enough to mitigate the condensation risk, highlighting the importance of a continuous envelope of thermal insulation. A properly optimised thermal envelope design encompassing both the walls and reveals may also reduce the required thickness of insulation throughout the building. In addition to Raptherm and Wall Liner, the high-performance Spacetherm Aerogel is available in a number of other forms. Spacetherm Multi uses a similar magnesium oxide facing to the wall liner board, but with an increased thickness of 6mm. This additional thickness allows the same board to be used in both floor and wall applications, making Spacetherm Multi a simple and versatile one-board solution to upgrading the thermal performance for all types of existing structure. Spacetherm Multi is available in both 2400 by 1200mm and 1200 by 600mm sizes, with the smaller size board being ideal for projects such as loft conversions where access may be restricted. The inherent moisture resistance of both the Spacetherm Aerogel and the magnesium oxide facings make it a great option for floors where the presence or condition of damp proofing may be unknown. Spacetherm Wallboard and Direct Fix. Where a more traditional finish is required, Spacetherm Wallboard offers a plasterboard finish with the same aerogel insulation as the multi-boards. This is fixed onto timber straps or studwork in the same manner as traditional insulated plasterboard, but offers significantly better performance. For applications where space is even more constricted, Spacetherm Direct Fix can be used to omit the requirements for the timber strapping and its associated depth. This board incorporates an additional layer of plywood to facilitate the use of shot-fired fixings into masonry substrates. The hydrophobic nature of the Spacetherm Aerogel insulation blankets means no additional protection is required on damp walls, making Spacetherm Direct Fix a one-step solution to thermal upgrades on walls with moisture issues. Both the wallboard and Direct Fix panels are supplied with an inbuilt foil layer for vapour control. However, if the design criteria requires higher permeability, this can be omitted on request, giving a more breathable wall construction and allowing the free passage of moisture. Spacetherm Cold Bridge Strip. Designed to prevent cold bridging through a component or element of a structure, Spacetherm CBS consists of a Spacetherm aerogel insulation encapsulated in polyethylene. Spacetherm CBS is an ideal choice for timber or steel frame structures, and on request can be cut to a variety of widths to suit different applications. In addition to timber and steel structures, it can also be used in other applications where cold bridging is an issue. Spacetherm Blanket. The Spacetherm blanket consists of unfaced sheets of high-performance aerogel composite insulation. The possible applications of the Spacetherm blanket are virtually limitless, as it has been used in doors, shutters, window reveals, boats, swimming pool covers and numerous other applications where thermal performance, space and thickness are critical. Spacetherm Slentex A2. The Spacetherm Slentex A2 range of laminates takes the high performance of the aerogel insulation and uses a carrier material with more limited combustibility. This sacrifices a little of the thermal performance, but takes the reaction to fire classification up to A2, giving an ideal mix of physical characteristics for applications which are both space limited and safety critical, such as limiting cold bridging in facade systems. Available in a range of facings, Spacetherm A2 can also be used to internally upgrade thermally deficient residential high-rise properties without compromising on fire safety. Spacetherm A2 is available as an unfaced blanket and also in the Spacetherm Multi, Direct Fix and Wallboard laminates. It can also be supplied in cold bridging strips. Hygrothermal Assessment Methodology. We've talked a lot today about moisture movement in existing structures, but how do we assess this and predict the effects of the refurbishment accurately? The BS 5250 and EN 13788 standards cover the assessment of moisture movement in buildings, and both have an important limitation which may lead designers to seek further guidance. Both standards rely on a calculation method known as the Glaser method, which was developed in 1958. Glaser uses steady-state heat conduction along with average monthly temperatures and the vapour pressures to identify vapour diffusion and model how vapour passes through the building fabric. This gives a reasonable assessment with a comparatively simple process and simplifies data input requirements. However, there are limitations. The main problem is that this method only models moisture vapour flowing from inside to outside and completely ignores the effects of external moisture sources such as driving rain. The model does not incorporate the effects of material porosity, moisture absorption and water storage in the building fabric. As stated in EN 13788, the method assumes built-in water has dried out and does not take account a number of important physical phenomena. The improved EN 15026 standard addresses these issues with the new calculation method based around dynamic numerical simulation of moisture flows. This type of simulation provides a far more detailed and accurate representation of the way in which moisture both flows and accumulates in the fabric of buildings, and is the method specified for solid walls with internal insulation in BS 5250. This more accurate simulation not only allows for greater variations in environmental condition and material properties, but also offers a more flexible approach to simulation time periods. Designers can look at minute-by-minute predictions on the building performance, taking many years into the future if required. This additional detail in time can often reveal small problems that can grow to cause severe issues over the years, issues which would be commonly missed by a simple Glazier method calculation. The trade-off to use this more advanced method is more complex simulation software and outputs which are more complex to determine. At the A Proctor Group, our team of technical advisors are trained to provide these simulations using the WUFI software developed by the Fraunhofer Institute, and we'll move on now to take a look at one of these assessments on a solid sandstone wall. Case study. In this case, we'll consider a typical solid existing wall with two skins of solid sandstone and a concrete rubble fill core. This is a typical traditional wall type found in many areas of the UK. However, in this case, we use environmental data for Glasgow and in the internal medium conditions defined in EN 15026. The model will be used to examine the performance over a 20-year time period to ensure any influence from construction moisture is eliminated from the assessment and a true representation of the as-built performance is achieved. We'll consider 4 different cases to upgrade this wall using Spacetherm systems. Firstly, the Spacetherm multi-system, with a thin 6mm magnesium oxide facing and no additional vapour control, giving a vapour permeable solution. Secondly, the Spacetherm wallboard, using a conventional foil-backed vapour check plasterboard facing. For both facing types, 10mm and 30mm of insulation will be used, representing both the bare minimum thermal upgrade and one achieving performance closer to modern building regulation standards. The first step in this assessment is to run the model with no insulation to determine which area of the building has the higher inherent condensation risk, to establish which represents the worst case. If the upgraded structure is modelled using this element, it can be assumed that other, less onerous elements will perform adequately. We can see from the graph here that the west elevation has the highest predicted relative humidity, and therefore the highest risk of condensation occurring. So having established the worst case scenario, we can now move on to a more detailed assessment of the wall construction itself. Here we can see the results of the modelling on the first case, 10mm of aerogel on a Spacetherm multi-board. The green line on the lower graph shows the relative humidity through the wall, and the blue line shows the moisture accumulation. In this, although both are higher than would be the case for a more modern wall construction, such as a cavity wall or timber frame, the moisture content is not increasing year on year. If we now increase the insulation thickness to 30mm, we can see the temperature gradient gets steeper through the insulation, but the relative humidity also increases as the inner surface of the stonework has become cooler. The moisture accumulation graphs are similar though, with no increase in water content. In the next case, we can see that by introducing a vapour check into the Spacetherm board, this serves to limit inward drying, increasing the relative humidity and actually increasing the overall condensation risk. The final case combines this moisture trapping effect with the increased relative humidity from increased insulation thicknesses, giving the highest overall condensation risk of all 4 cases. As can be clearly seen, the permeability of the Spacetherm multiboards allow for a greater drying out of the construction, as this is possible to both the interior and the exterior of the building. This results in much greater swings in the value of the relative humidity, but the values are lower overall than when the vapour checking Spacetherm wallboard is used. If we then look at the water content of the stonework, this can also be seen to be lower when thinner and more permeable insulation is used. So, considering all of the above, the risk of condensation, counterintuitively, is lowest when we omit the vapour control measures and limit the insulation thickness. The additional detail presented in this more complex assessment also allows the designer to better quantify and hence manage the specific risks associated with this insulation upgrade. Case study, Bath Townhouse. The heat efficiency of a Grade 2 listed Georgian townhouse in the historic city of Bath is set to be dramatically improved as a result of the introduction of Spacetherm multi-insulation. The challenge of dealing with heating inefficiencies, major heat loss and heating costs are a common problem with many listed buildings and solid wall dwellings. Property owner Mike Moore obtained planning permission to insulate the top floor of this Grade 2 listed Georgian townhouse, as it is single skin 6-inch Bath stone and very heat inefficient. All walls have the original lime render and skim, so they need to breathe. The property in Bath was built in 1818 and has been in his family for 101 years since 1919, so it needs some serious upgrading. The project was initially specified utilising 100mm of conventional insulation, necessitating moving door frames and rebuilding window reveals, as well as a fair amount of lost floor space. Mike's research led to Spacetherm, however, and working with his architect, he was able to reduce this to just 20mm using Spacetherm Multi, reducing the associated disruption while still delivering a meaningful thermal upgrade which was acceptable to both building control and conservation officers. A lime plaster finish was applied professionally by a contractor upon completion of the installation, complementing the permeability of the Spacetherm systems and protecting the original stonework. Finally, Mike Maurer commented, "I think Spacetherm Multi is ideal for a listed building insulation as it has a minimal effect on the infrastructure of the original building. It has the potential to be used extensively in old buildings, such as we have in Bath, where heat loss is at a maximum. The original walls need to be able to breathe when insulated, and I'm also seeking planning permission to use the product to insulate the basement floor and walls." So, we've seen how effective modern high-performance insulation can be, but also how carefully we need to consider the effects and implications of anything we do to upgrade older buildings. A lot of this is very project-specific, and our technical team is able to help specifiers assess and mitigate any problems before they arise. With that in mind, as we move into the Q&A session, it may be that we need to follow things up by email and run calculations more than normally would be the case for these sessions. Our team of experts don't just work on Fridays though. They're available either online to drop into virtual meetings as needed, by email or instant message via our website, or even just on the phone. So they're available to provide advice in whatever way suits your workflow. I'll now pass over to Carol and the team for the Q&A session.
Good morning, everyone, and thank you all for joining us again today. Apologies for the slight audio issue we had at the start. I hope you didn't miss anything. My name is Carol Michalak, and as Kira mentioned at the start of the presentation, I will be hosting the webinars while she is off on maternity leave. I do hope everyone is still keeping safe and well, and that you're looking forward to the weekend. It's really, really nice to see the weather getting a little bit brighter and a few of our restrictions being lifted, with hopefully a few more soon. Although unfortunately, up here in Scotland, we still have another week and a half before our hospitality opens. Patience. If you are new to our webinars, welcome. Please stay with us as long as you can for our Q&A session. We aim to stay on here and answer as many questions as possible. So please feel free to post them in the YouTube chat here, or you can send a direct message to our Twitter page at Proctor Group, or you can drop us an email to webinar@proctorgroup.com. Now, if you can't stay on to the end, or you simply have to leave early, don't worry. Please just leave us some details and we will get back in touch with you directly. Now, if you have registered today, and don't worry, you still have time to if you've not done so yet, you will get a follow-up email from us with details on how to watch back the webinar and also request a personalised CPD certificate. Please forward this on to any of your friends or colleagues that you think may find it interesting. Now, if you'd like to see any product samples or arrange a virtual meeting with one of our team, please do get in touch. We'd be delighted to have a chat with you and find out what you're involved in and hopefully help with future projects that you've got in the pipeline. Now, we've already had some absolutely great, fantastic feedback on our webinars, and we do appreciate the time you take to give us this. It all helps to shape the content for future presentations. Every bit of feedback does get read, so please leave a comment, give us a thumbs up, and subscribe to our YouTube channel, where you will get notifications on all the things that we're involved in and all future webinar content. You can also watch back any of our previous webinars, and these can also be accessed either here on the YouTube channel or from our website at www.proctorgroup.com, where we have our webinars and also a learning hub page with lots of content to watch back. This is actually, if I worked it correctly, our 25th webinar that we've presented since we first went into lockdown at the end of March last year. So there has been quite a range of topics covered, and hopefully you'll find something relevant and interesting. As I mentioned earlier, we have received some fantastic feedback for our webinars, and we actually won a couple of awards at the end of last year, one of which was Best Use of Content Marketing in relation to the webinar series, and also a highly commended trophy for the Marketing Team of the Year, which is amazing. We cannot thank everyone involved in making these enough, and that does include you for registering, watching, commenting, and staying with us. So this brings me nicely on to our next webinar, which is now available for registration on the website also. This will take place 2 weeks today, on Friday the 30th of April, at the usual time of 10 AM. A more specialised topic for this one again, being building on radon sites. Now this webinar will feature a very special guest presentation from Michael Hancock, who is the Director of Glencoe Radon Gas Centre. This is sure to be another very interesting and relevant topic, so please register your interest now. Let's move on now to our Q&A session. No special guest with us here today, although to me, these guys are definitely special in their own individual areas. All familiar faces on the panel, however, let me introduce you to them all again once more. We have with us Ian Farrington, who is our Technical Director. Good morning, Ian. Oh, you're still on mute, Ian. We have with us Ian Farrington, who is our Technical Director. Good morning. And we've also got James Brackenreid-Johnston, who is our Specification Manager. Good morning, James.
Good morning, Carol. How are you?
I'm getting better.
Good.
And we have also got with us Adam Salt, who is one of our Regional Technical Managers. Good morning, Adam.
Morning, Carol. Morning, everyone.
Good morning, everyone. Great. Okay, I am really, really pleased to see that there are quite a few questions come in already. Do bear with me whilst I collate them in from different areas. Here's one. Let's start with one. If I could put this one to you, James, if that is okay. Linda Young on the YouTube channel has said, can I use a VCL with Spacetherm?
Indeed, it's obviously something that we assess whether it's a new build project, whether it's a retrofit project. We'll obviously establish the build up with you. If it's more so on the retrofit side of things, as Kira mentioned during the presentation, we'll carry out a WUFI analysis on that build up. And therefore, if a VCL needs to be integrated into the build up in order to make sure that the condensation risk is kept to a minimum, then that's what we'll do. From the perspective of Spacetherm in general, obviously because of the vapor permeability of the product, the intention is always to allow, especially on the retrofit side for a solid wall system, is to allow that vapor drive through that external envelope. But ultimately, with the change in humidity class within a property, if the heat source is changing, if the usage of that room is changing, and therefore, indeed, the humidity class of that room is changing or the building is changing, then we'll apply the correct VCL to the build-up in order to make sure there's no risk of condensation build-up or interstitial condensation within that build-up. So ideally wise, obviously from a retrofit perspective, we'd like to remove the VCL to allow that building to naturally breathe as it has done since it was built back in the day. But ultimately, we've got to be pragmatic about it with modern methods of heating, with modern materials and electronics that emit a lot of heat. Within these properties, we need to make sure that the correct humidity class is taken into consideration when doing these calculations. So ultimately, get in touch, send us the information in regards to the build-up, what that room, what that building is being utilised for, and then we can make the correct assumption from there.
Perfect. Thanks, James. Okay, let's move on. There's another one come in for you this time, Adam, if that's okay. Craig Thompson has asked on the YouTube channel, is it better to insulate internally or externally for my solid wall property?
Thank you, Carol. It's a question we get asked quite a lot, actually. And well, there's a number of things to consider when you're choosing whether to go sort of internally or externally. First of all, I'd say, what's your type of property? Is it old with lots of unique features that don't want to be covered up, particularly like properties in Bath, for example, like the case study in the webinar. The property could also be listed, and then planning wouldn't allow it as well to go externally. So therefore, in those situations, we'll be looking for internal insulation, ideally. And if these features don't apply to your property, then we're going to be looking externally as the options, because then we're reducing thermal bridging. So externally is ideal from a design point of view, but in some cases we can't. You then also got to consider what sort of type of lifestyle you live. For example, if you're the type of person who constantly goes in and out of your house, you go to work, you come back, have some dinner, you take the dog out, you then come back, get ready to go out again for the evening, then you're more suited to internal insulation. And that's because you've got a higher thermal mass externally. This means you get a quicker response from your heating. If you're like me, however, who's at home all day, sat in my home office, and don't leave the house for long periods of time, then you'll be more suited to external insulation, because although it takes longer to warm your property up, once you turn that heating off, the heating is retained for a lot longer, because you have a higher thermal mass internally in that sort of method. But yeah, a number of things to consider. Hopefully there's a couple of ideas for you there. Thank you, Gary.
Thanks, Adam. Okay, Ian, your turn if that's okay. There has one come in on YouTube from Michelle Paul. She has asked, is glacier not just as good for a condensation risk in a solid wall?
Yeah, good questions. The glacier calculation is a good system. It can work in quite well, give you a good snapshot of moisture risks. However, the WUFI calculation does go on that bit further and give you a better idea of actually what's happening. As the presentation said, it gives you an indication of moisture from the outside, especially in solid walls where these could be essentially mini reservoirs with the built-in moisture that's in there. So the WUFI calculation does give a much better holistic approach to the moisture that's in that building and how it dries out. So it's one that we would recommend for solid walls, not necessarily for new build that's dry and you don't have any built-in moisture, but where you do have built-in moisture, that's always a good way to go.
Perfect, thanks, Ian. Whilst I've got you, I'll put another question to you if that's okay, Ian. This is coming from Kevin Davidson on email. Kevin asks, do we need a primer when plastering on the MGO boards?
Yeah, MGO boards are slightly different to plasterboard, obviously. So it would be better to use a primer, and we do recommend a primer when you're using our MGO boards. It's not just a simple PVA primer that you would use with normal plaster. We recommend a plaster bond that has a little grit in it that gives a better key when you're plastering. So you can plaster in the normal way if you use that type of primer. One thing you've got to remember though is you're insulating your house now. So the dynamics of your house has changed in that room because you're now insulating. So you've got to allow more time for drying out and make sure that you take your time and let the construction dry out, and everything will be fine. You can use that primer.
Perfect, thanks, Ian. James, if it's okay if I can come to you with this next one. This has come in an email as well from Gavin in Manchester, who asks, can I use lime plaster on the MGO boards?
You can indeed. I mean, as Ian mentioned, utilising a primer is key. So obviously we'll establish exactly what you're using and what's going on, and then we'll sort of give you the right primer to go for in regards to that. But in regards to lime plaster in a modern sort of heated building, with obviously all the electronics, it's well worth taking into consideration, obviously, the drying time of lime plast. Because obviously when it was originally utilised, obviously the buildings were cooler, it would take a lot longer for the lime to cure, and this, or to dry, I should say. And this still needs to be the case, because the product still needs to dry in the same sort of slow period of time that it does. If you've got central heating on, then obviously it will dry the plaster quicker, which will obviously instigate cracking fairly quickly within the product, because it's not drying out in its natural way. So it's well worth taking into consideration the time of year that you're doing, if you can naturally ventilate the property to allow that drying process to happen, as opposed to utilising mechanical heating, then that would be a great way of doing things. It's worth noting as well at this time that if you're thinking of using the lime plast and you have an uneven or curved wall, you can utilise the Spacetherm blanket and utilise your, from a historic basis, your chestnut laths. I'm sure there's plenty of other timber laths that are available now instead of the MGO, as long as there's a mesh between the Spacetherm and the lath for bonding. The mesh is required due to the hydrophobic properties of the insulation, so it naturally repels moisture. So therefore, obviously, the moisture within the lime plast would try and bead and not bond back to the substrate. So the mesh allows that bond to happen. Otherwise, obviously, you can, rather than having centers between your laths, you can literally have sort of 5 to 6 mil centers between those laths, and then that will do the job as well at the same time. But it enables sort of all coverage around, obviously from the antiquity side of things, you've got a lot more uneven and curved walls out there than in modern build-ups. And indeed, obviously, as the buildings get older, you do see the brickwork, blockwork, sandstone walls move as well at the same time. So it'll cater for those areas as well.
Perfect, thank you. You might actually, James, have covered a bit. Adam Fussett put a question on what exactly is the method used or recommended to use lime plaster onto the insulation, and what exact fixings are recommended. Can you add anything else on for that one?
In regards to fixings, it's obviously quite a point that people need to know about, and obviously what we can do is say we've tried and tested with quite a few different manufacturers of fixings. Obviously, it's not something we supply ourselves, but we've asked fixing manufacturers to test with the Spacetherm, with the A2, with the different composites of each product as well, and obviously the associated fixings to go with. In all honesty, from the point of view, make sure it's long enough, make sure you've gone into your substrate to a decent depth, but prior to that, make sure your substrate's in a decent condition before you start drilling into it, before you start direct fixing into it, to make sure that it's going to take the impact of those direct fixes, or indeed that it's not going to be, the integrity of that wall's not going to be jeopardized by using the fixings. But stainless steel flush head fixings are the sort of ideal way to go. And I don't know if I can mention, Ian, the names of the companies that we've been to in order to get them assessed. But there are multiple fixing companies within the UK that you can speak to. Otherwise, speak to us afterwards, and we can obviously give you the names of those companies.
Perfect. Thanks, James. One here for you, Ian, if that's okay. Stephen Howlin has asked on YouTube, are the Aerogels insulation products agreement certificates available on the BBA website or the NSAI website?
The Spacetherm doesn't have a BBA certificate. We have gone with LABC for all our Spacetherm products. So that what we decided against the BBA. We decided to go with LABC to show its fitness for purpose, and they're all available on the website. So.
Perfect, thank you. Whilst I've still got you, Ian, there's another one from Nigel Shapeland on YouTube again. When used for floor applications, are there any load-bearing issues?
Yeah, it's a good question. It's a flexible material. So it can compress. It's good for load bearing for floor applications, but if put too many layers together, we advise that you take it very slowly, and there's a maximum amount of insulation that you should use in that area. In floors, you don't necessarily need so much insulation, but we do recommend that you take the load bearing off the structural floor rather than the insulated floor.
Perfect, thanks Ian. Okay, Adam, let's move back to you if that's okay. I have one here from Melanie in London, who's actually been in touch via our Twitter page. Melanie asks, do you have any U-value examples with using your Spacetherm product?
Yes, we have a lot of them mainly in our literature. As an example of one now. You can find them on our website or get in contact. We're happy to send you some on PDF or down to your properties. So yeah, you can get numerous examples there, all different type of build-ups, following all of our sort of Spacetherm range. The one I use most often as an example though, is if we take a 225mm brick wall with no insulation, that U value will be around 2.06. If we were to add our 13mm Spacetherm wall liner, so that's 10mm blanket with a 3mm magnesium board, then the U value is then improved to 0.81. So we can see a vast difference there from 2.06 to 0.81. I think that's a 61% heat loss reduction, which for 13mm is kind of a massive improvement. But yeah, you can find that all in our literatures. Like I say, they're available on our website, or get in contact.
Yeah, like Adam says, our website has a huge amount of information on there that can help you. You can engage in a web chat with our tech team from the website if you need to ask anything whilst you're having a look, but there's lots of information there. Have a look around there. Whilst I've got you, Adam, a good one's come in from Adam Fuss on YouTube. What is the exact type of tape used to seal the edge of the insulation after cut? Is that one you can help with?
Probably not. Maybe Ian might be able to help more with that one, to be honest.
Ian?
Yeah, to use a good technical term that me and my team use quite a lot, it depends. We don't necessarily recommend that you do need to put a tape around the edges where it's cut. Depends on the application, hence the word depends. If it's not exposed, there's no problem at all. So if it's behind a plasterboard, you're cutting the board, it's usually got a tape and fill over it, or it might even have a plaster, as we mentioned earlier. There's not really a recommendation for any tape. Perhaps in the floor, so going back to Nigel's question earlier, in the floor, sometimes that compression could create a dust, so you maybe have an overscreen of a membrane to stop that dust coming up that might be evident with the dynamic nature of the flooring. But really, there's no set recommendation for a tape around the edges.
Perfect, thanks Ian. James, if it's okay, I put this one to you. On YouTube, Martin Noon has said, does the internal surface need to be flush to achieve a tight fit with the aerogel, or does it matter? For example, a rubble stone wall surface. I think you touched on this a little bit earlier as well.
Yes, I mean, it's obviously the material itself, as in the name, it is a blanket, so it will cater for imperfections within the substrate. If you've got sort of, if you've got curvature, if you've got sort of slightly juxtaposed brickwork, rubble stone wall, there's a multiple different. You're talking about flint block wall or something on that sort of line, then maybe it's a little bit too much. You may need to juxtapose the internal wall, so do a new stud and track sort of offset from that internal wall to shore it up. But again, to kind of phrase from Ian, it does depend upon the actual condition of the substrate itself and how unflush that wall actually is.
Perfect, thank you, James. Let's go back to you, Ian, if that's okay. We've got an email coming from Emma in Bristol. Morning, Emma. Do I need to insulate all the walls in a refurbishment?
Yeah, that's a good question. It's one that sounds obvious, but it's not necessarily always the case. And we've been looking at refurbishing my house, whether we should be all the potential hassle of insulating the walls. And I was trying to explain to my wife that it's only the external walls that have to be insulated. The internal walls don't need to be insulated, so there's not so much disruption. And that sounds obvious, and it could take, you think that there's a big problem here, that there's a big refurbishment required, but you only have to do the external walls. When you actually look at the external walls, by the time you get your windows and doors taken out of the consideration, there's not a lot of external walls, and it can make a big difference though to insulate those external walls. Obviously, you want to be doing the reveals as well. So if you do the reveals, just as it said in the webinar, the reveals are really important. So do the external walls only. We had a project recently where the client was hesitant to use to insulate their house because they had a beautiful bookcase along one wall. Once we explained that they wouldn't have to move that bookcase because that bookcase was on an internal wall, the project became a lot simpler for them, and they went ahead and insulated the building because it was only the external walls that they did.
Perfect, thanks, Ian. If I could just stay with you again, actually, we have a question from Matt, who sent this in to us on Twitter. Why can't we use natural materials in refurbishment?
That's a brilliant question, Matt. Natural insulation products are great, and they have so many great attributes. Hemp, sheep's wool, breathability, insulation, there's just so many good attributes. The problem is the cost, and not necessarily the monetary cost, it's the cost of space. So hence the range of our products are called Spacetherm. That's because we're reducing the space required. When you put an insulation in here of a natural material, you can add so much depth to the walls that it can be problematic. We had a project in Glasgow where the architect was intent on getting new build regulation thickness of insulation, but he wanted to use a natural material like a hemp or sheep's wool. The problem with that was that if we did that refurbishment to that thickness, one of the bedrooms, you wouldn't be able to get a bed in by the time you insulated round, even just the external walls. There was 2 external walls in this bedroom. By the time you put that in, you wouldn't be able to get a bed in there anymore. Or if you did, you'd have to take a flyer into the bed because you wouldn't be able to walk into the bed. So those insulations are fantastic, but remember, it's the balance of what you're looking for in terms of breathability, along with the thermal performance. And that's where Spacetherm gives you such a great solution to allow you to balance.
Perfect, thank you, Ian. Okay, can I come back to you now, Adam, if that's okay? We have an email in from Jamie Simpson. Now, this is something I do know we get asked a lot about. Do you have a list of approved installers for Spacetherm?
Yeah, we do get asked that a lot, and no, we don't have any approved installer list. We say anyone with a general trade background in dry lining should be able to install our products. Again, referring back to our website, we have installation guides available 24/7. We can also send you for all of our Spacetherm solutions. We've got a technical service that you can also ask, and regional managers across the whole country that are happy to help with your projects. So we've got plenty of sources there to help you with the install. I worked on that Georgian property in Bath that's mentioned in the webinar. The client didn't have any trade background and did the install himself. He did a lot of research into aerogels and Spacetherm before using it. He spoke a lot with our technical department and myself, which we'd always recommend. The client did, however, also get a tradesman in to do the plastering, but the actual installation of the boards he did himself. And in regards to Richard Wolf, who mentioned details around the floor joists, I'll have a conversation with the client, see if I can get him any information over on that one. So yeah, thanks for that one coming in on that.
Perfect. Thanks, Adam. Just whilst you're mentioning McDaniel Wolf there, you'd asked a question at the start regarding British standards. Are you able to give us a little bit more information? There's two of them mentioned within the presentation, but we're not sure what you mean by the third one. Send us a little bit more details in and we'll have a look at that and get back to you on that one.
I think also we'll send out the webinar to watch, so you can watch it back. So you should be able to find out which one you're after on that.
Thanks, Adam. Just whilst I've got you, if I can give you one more. This has come in on Twitter from Davin Krychek. Davin has asked, you mentioned that some Spacetherm solutions use an MGO board and others use plasterboard. What are the differences between the two?
Oh, right. Well, yeah, I think in the webinar, and again, we offer both. And it really depends on the project requirements. We mainly use NGO boards because they're stronger than plasterboards, and this allows us to save space. So in the wall liner example, we can use 3 mil there. When the multi, we'll use 6 mil NGO boards. And if we compare that to other insulation systems that might require 12.5 mil, there's a space saving there, which again is a benefit of the product. Another reason with MGO is breathability. The MGO boards that we use are much more permeable than the plaster boards that we use, which results in better drying out, especially for sort of historic buildings that Spacetherm suits itself for. So Spacetherm is one of sort of the best products out there for retrofit of solid walls, not only because of low thermal performance, but allowing for a thin solution, but also with Spacetherm being breathable. And we want to continue that breathability into the internal finish, which is why MGO is sort of a preferred option for these projects. But also we do recognise a lot of projects want to potentially use plasterboards, so we have that as an offering as well. Yeah, thank you.
Excellent. Thank you, Adam. Okay, Ian, if it's okay if I could come back to you. Ali Aratesh has asked on YouTube, what is the gel in Aerogel?
Gel in the Aerogel is a silica. Part of our marketing team who put this presentation together with a puffed out rice crispy idea, which explains exactly how that insulation works very well. So the silica is actually sand that's used, and that's what gives it a lot of its properties. That gel is then put into a tub, big bath, and then the carrier is put into there, which impregnates the gel into the carrier, and then you come up with a product such as the Aerogel product there, which becomes a lot more robust with that brittle gel inside it.
Perfect, thank you. I do like it when you all bring samples to show everybody.
So competition we have.
Yes, we do. Yes, we do. I feel left out. Right, let's move on. Perhaps, James, perhaps you can answer this one from Ensign Design on YouTube. Are there health and safety concerns in cutting the Aerogel or the MGO board?
It's just like any other product, really. To be perfectly honest with you, you need to, if you're cutting internally, then you need to make sure that you're wearing a dust mask and indeed have correct ventilation. From cutting the Aerogel, you can utilize Stanley knives, you can use mechanical blades in order to cut the material, but just make sure that the ventilation is there. And if the board is combined with an MGO board, again, same sort of process, goggles, mask, and ventilation. Ideally wise, if you can cut the material outside, which will obviously reduce down the requirement for mechanical ventilation.
Perfect, thank you. Ian, if I can come back to you. We have one here. What have we got from Stephen in Lincoln? He's emailed this one asking, what is the best product to reduce cold bridging for lintels?
That's a brilliant question because I've got a great sample. So, sorry, team, I've shown you up again. This sample that I was showing earlier is a product that was described in the webinar called Raptherm, where it's used for the facade. But this product is really good. It's got the wrap-tight, airtight, vapor-permeable membrane with the self-adhesive backing. And we've bonded it to the aerogel, so we've got Raptherm. And this can be used, as it said in the webinar, on the facades, but it also is very good and it's used a lot for lintels. So we can bend it around the difficult lintels. And because it's self-adhered, you don't have to put mechanical fixings in through the steel lintel, for example, or the concrete. So it can be stuck on the cold bridge, formed into the difficult, sometimes the I-beams or whatever, the lintel size, and it provides a beautiful thermal bridge right round that whole area. So that's what we would recommend for that.
Perfect, thank you. Whilst I've got you, Ian, Gemma Thomas has asked on the YouTube feed, is the Aerogel product a good acoustic insulator?
That's a great question. Insulators, people think if it's a good thermal insulator, then it's a good acoustic insulator. So rigid boards, for example, can be really good thermal breaks, but they become acoustically transparent because of their nature of their rigidity. Glass wool, rock wools are very good acoustically and thermally as well. With Aerogel, we've done some internal testing for its acoustics, because that was the next natural progression. We've done some floor tests, and the absorption of it was very good. It wasn't good enough from a competitive price point of view, compared with polyethylenes that you may use, that we use in our other acoustic systems. So it can be used acoustically. The majority of times it's used more for thermal insulation, so it'll be on ground floors where the acoustics of the floors are not as such a requirement. So yes, it can be, but it's not used for that application very often, but it does have a degree of absorption in the application.
Perfect, thanks, Ian. Adam, if I can just come back to you, following on from what you mentioned earlier. McDaniel Wolf has come back saying, thanks, Adam. On my requirement, I just needed the third British Standard reference number.
Yeah, without going back through the presentation myself, I think we referenced the BS5250, the EN13788, and the EN15026. I'm not sure if we reference any more without going back through it myself. But hopefully one of those might be the answer to your question. If not, again, we'll go back through the presentation and find out for you.
Perfect, thank you so much. Okay, I've only got a few more questions here. If anybody still has anything they'd like to ask, please put it into the chat now or send us a message with your details and we'll get back to you. James, if I can come back to you again, I've got an email from Jeff Byrne who asks, do I need to batten out behind the Spacetherm?
You can do indeed, if the requirement is there. Obviously, it'll encroach on your internally usable space, but ultimately, if you're intending to put services behind there, then it will need to be battened out in order to put those services in. If there's specific items such as kitchen units or televisions or wall cabinets, whatever you're looking at being put onto that wall, then yes, definitely batten out prior to, in order to make sure that you've got anchors to put those materials onto. It's again with the substrate condition, always look at what you're going onto first, make sure it's in decent condition. So if any jointing work needs to be done, repointing work needs to be done, so to speak, if you've got exposed brickwork, blockwork, then just make sure prior to any IWI installation that this occurs to negate any failures of install.
Perfect, thank you. As the guys are always saying, you know, a lot of it just does depend. It's not a cop-out, it's not that they don't want to answer your question, but a lot of it will always depend on each individual application that you have. So if you're unsure, please just pick up the phone, go on a web chat, send us an email, get in touch. We will always do what we can to help you. Now, I think this might actually be our last question, certainly the last one I can see so far. Which, James, if I can stay with you, if that's okay. This is in from Libby Gregg, and she has emailed in saying, with the A2, if you bond the boards together using glue, whether insulation, plasterboard or MGO, does the system still achieve A2?
Indeed, it's a question that we get asked a lot in regards to the A2 product, because obviously there's a lot of buzz about A2 products at this moment in time because of unfortunate events that have happened in the industry. What I'd say is that the A2 and indeed the Spacetherm, the A2 comes in 10mm increments, as opposed to providing a 40mm board. Will provide 10mm board glued together 4 times in order to create that 40mm, and obviously thicker if required, or thinner. With the Spacetherm, you can go up in 5mm increments, but again, that product is bonded together. In regards to the A2, because we're introducing a glue, which again is an organic compound, there is a very, very small calorific value of that glue, and therefore to classify it as an A2 is a no-go for us from that point of view. If you want to maintain that A2 standard, utilizing the 10mm boards mechanically fixed independently, so you literally put a 10mm board up, or you put 3 layers of the 10mm up and then mechanically fix that into the substrate or onto the SFS or whatever system you're utilizing, then you will achieve the A2 rating.
Perfect. Thanks, James.
Again, as you said before, get in touch. We'll go through it with you. We'll work through the build-up with you. We'll work through your detailing and then go from there.
Absolutely.
Carol, if I could just add to that, it's a great answer, James. The difficulty we've had is the learning curve of the fire regulations, and we simplistically assumed that an A2 insulation plus an A2 plasterboard equals an A2, but we realised that A2 plus A2 doesn't equal A2 because we've got that glue line, and you've got to take all that into consideration. It's very good answer that you gave there, Jim, because that's exactly the position we're in. We don't want to be informing the industry. We have very good products, but holistically, we've got to be correct with how we promote it.
Absolutely. Ian, there's a last question just come in there, if it's okay for you to answer. Martin Noon has asked, is there not an additional condensation risk increased if you batten solid wall?
If you batten the additional wall, trying to think of an answer that doesn't say depends. Anybody help? I think it, you would have to see the construction. If you're bringing air and moisture-laden air into that area behind the insulation, then there could be that additional risk. Because we're now dealing with that batten space being on the cold side of the insulation. So that's what we mean the outside. So it's a potential risk, but I'm going to have to say it depends on whether there's air movement in there or not. If there's air movement in there and they're bringing moisture into that area, and it's on the cold side, then there could be that risk there. If it's just an air cavity and there's no air movement in there and any subsequent moisture, then it should be okay. But we would have to see the construction and be able to give a definitive answer on that. But not necessarily. Is that a better word than depends? I don't know. What do you think, anybody?
It's probably worth noting as well that if you're going to be battening onto a solid wall, then predominantly most of the time you'd be utilising a DPC behind that batten. in order to make sure there's no moisture ingress into the back of the timber, or indeed that can travel through the timber to the back of the internal lining from that external wall. So you're reducing that sort of condensation risk by negating that condensation getting into that timber and building up in the timber from there. Obviously timbers are treated, but obviously over a period of time, then that treatment sort of gives up the ghost. So it's always worth having that DPC behind there. And indeed, you've got the cold bridging strips, which can be utilised to negate that cold bridge as well. So which will in turn reduce that condensation risk down again. But if you look at rigid board manufacturers, especially when it comes to solid wall systems, they will always stipulate there needs to be a cavity behind there, because obviously where the moisture comes through the solid wall system, the idea is that that cavity will warm up, and therefore it will allow that moisture to evaporate off.
Thanks, James. Sorry, I was just quickly reading the last. David Thomas has said, well said, it could be a warranty requirement for an independent living system.
Lining,
sorry. Take my glasses off. Right, I think I've pretty much covered all the questions. If I have missed anyone, my apologies. We will go back through everyone just to make sure we haven't missed anything and contact you directly if something hasn't been covered. Thank you to our panel today. Please register now for our next webinar covering building on radon sites, taking place 2 weeks' time. Don't forget to subscribe to future content on our YouTube channel and leave us some feedback. So I think that's it for today. Nice short and sweet one for us today. Thank you all for joining us once more. Look after each other, keep safe, and enjoy the rest of your day.
Thank you. Bye-bye.
All right, thank you.